Hi, everyone. Well, it's not strictly about WebSockets, the presentation. The title is WebSockets Turning Physical Motion into Virtual Motion, and this is what we're going to be focusing on. So you can follow me on Twitter. It's CyberCity, PSYBERCITY. So please follow me, tweet photos or anything, and I can follow you back. So we're going to start with a little tale. That is my mother there. You can laugh at your joke. But that is my mother there, and that is her mouse. So my mother is not so tech-savvy. She's not so accustomed to technology. So a few years ago, I gave her my old laptop. And I taught her how to use it. I taught her how to use her mouse. She had a mouse like this, an optical wireless mouse, as we all have, I presume. And she got used to using it. And then one day, after the years passed, some of her friends told her, "Oh, Sophia, we're watching online movies from our computer, so why don't you do it?" And she told me, "Katerina, I want to watch online movies." So what I did was I took the laptop, I connected it to the TV, and I gave my mom her mouse, and I told her, "You can sit comfortably on your couch, the TV is going to be right there, and you can control your computer with your mouse as you were doing normally." So I set it all up, I left the house. 10 minutes later, the phone rings, my mother is in panic mode. "Katerina, it's not working, the mouse is not responding, the cursor is not moving, something is broken." I tried to troubleshoot via the phone, the mouse was on, so I couldn't understand what the problem was. I went back to the house, and I saw my mom holding the mouse in the air and doing like this. Yeah, obviously, she didn't know that the mouses have an LED light and a light sensor, and they actually need a surface so the LED can be reflected and be read by the sensor so that it can read this motion on the surface. She didn't know that. So I thought, why would she need a mouse? Why couldn't she just use her physical motion to control the cursor? And I suppose that's what the people on Nintendo thought, and they made Wii. But I also thought that why couldn't she use a device that she already has, like the mobile phone, which is equipped with these sensors, the gyroscope, the accelerometer, that you can move them, and they can actually record that 3D motion. And why not make something that doesn't need any application to be installed and doesn't need any application to be installed in the laptop and can just use JavaScript? And that's what we're going to see today. We're going to use the device sensor APIs that JavaScript has natively, and we're going to build something, and we're going to also use WebSockets on the way. So, after this brief intro, we're going to see how to capture this device sensor data with JavaScript, how to send it to another place, your desktop or your laptop computer with WebSockets, and how to translate it into virtual motion, like to actually see how to create the interface or the interactions. And in the end, we're going to try it all out together in a nice demo. So a little bit about myself. I'm a front-end web developer. I work at Upstream, Greece. I studied spatial analysis and spatial data visualization at UCL. I worked a lot with Angular, with map APIs. If you see my previous presentations, they're all about maps. And some visuals, which we're going to see today. And I live in Athens, Greece, and I code with my cat on my lap. That is my cat there. OK, so why do we need such an interface? We're making an interface that uses physical motion. This could be used in games. Again, think of Wii. Like you can do like this and move a racket or whatever. And it can be used by people who are less accustomed or less able to use other methods of user interaction, such as the mouse, the trackpad, the keyboard, or the voice, the camera, the other methods of user interaction. So our tools for today are going to be WebSockets, actually the Socket.io library, Angular, and the device sensor events, the motion, the orientation, and the light. So why will we be using WebSockets? We want an uninterrupted connection between our two clients, the phone and my laptop here, and the server. So WebSockets, what WebSockets give us, they provide us with an interactive communication session between the user's browser and the server. We don't have to poll the server for replies, so you see these device motion listeners, they listen for motion events, so they produce sort of a stream of data. So we want to constantly send this data as messages, so we don't want the server to poll us each time to request messages. We want this to be seamless. We want a persistent connection to do just that. We want to be bidirectional, so we're going to have just one WebSocket server that's going to receive and send back messages. So this is a full duplex communication. And we just need a single TCP connection, so you don't have to worry about TCP handshakes each time you're polling the server. So we're going to be using Socket.io to do that. Socket.io uses WebSockets when it can. So we want to make sure that we're going to establish this seamless connection, this uninterrupted connection. So we're using Socket.io, and Socket.io will run a feature detection, and it will understand if the connection, it will tell if the connection is going to be established with WebSockets or with Ajax long polling or with Flash, etc., so it can work anywhere. Why Angular? Well, you don't have to use Angular to do this application. However, I chose to use it, and we are going to use it, and we're going to utilize the RxJS library. There were some nice talks about RxJS, so I'm not going to explain how it works. Even if I wanted to, I couldn't go very deep into it. But we're going to be using RxJS subjects, which are both an observer and an observable, which means that they can both listen to and send messages, which is what we need to use WebSockets. And so what the subject, the RxJS subject basically does is it watches for the WebSocket, this open connection, for incoming messages and broadcasts these messages to any components that are subscribed to it and use. So I relied heavily on Elliot Forbes' tutorial. You can find the link at the end of my slides to make this work with Angular and Socket.io. So let's talk about now the device sensor events, the third thing in our tools. First, we're going to use the device motion event. So we're going to use acceleration and acceleration including gravity. These are two different measurements that our phone provides. And it gives us the acceleration of the device on 3 axes, x, y, and z. And acceleration is expressed in meters per square second. So it's the code to read that in JavaScript, it's that simple. You add an event listener to the window, which listens for device in motion, and it fires an event each time the device is moving, and the events can be accessed like this. So, as you can see, as we are moving our phone around, if you see the first column, the numbers are changing. So if I have my phone resting on a plane, this is the z-axis. So in the z-axis, because we're using the acceleration, including the acceleration of gravity is 9.8, so it's 10. But if we start moving it, the other numbers change. So how do accelerometers work? Roughly, obviously. Accelerometers are usually made of piezoelectric materials. Piezoelectric materials are materials which their charge changes as they are pressed or they are moved. So these are usually quartz crystals. So the acceleration that we're doing moves these crystals, and they load these elements according to Newton's second law of motion, which the force is the mass by the acceleration. So that force can be observed in the change of electrostatic force, as we said, of voltage. So this change can be recorded by our device. The other event we're going to be looking for is the device orientation event. So we'll use the alpha, which is the motion of the device around the z-axis, the beta, which is the front and back option around the x-axis, and the left-right motion around the y-axis. So again, it's just a simple event listener which listens for device orientation. So if you look at the second column, you can see that the numbers are in ranges. So the first number is in a range from 0 to 360. So if we move it like this, if we have it like this and we move it, it's from 0 to 360, the x-axis and the y-axis. So again, these, oops, I exit the browser. So again, these events are captured using a gyroscope. A gyroscope is a device right there. And okay, first I'm going to show you. I have brought the gyroscope with me. This is a mechanical gyroscope, but actually in our phones, they are micro electromechanical gyroscopes. But the principle behind the gyroscope basically is the conservation of angular momentum. So when a vibrating object, okay, let's take it from the beginning. A vibrating object tends to continue vibrating in the same plane even if its support rotates, because you have the inertia law and you have to conserve the angular momentum. So you have each time you have a vibrating object or a rotating object, the Coriolis effect takes on and it causes the object to exert a force in its support. And by measuring this force, the rate of the rotation can be determined. So as we're moving it, it tends to return to its original position. So this force is calculated and it's passed in our system and can be measured. So you have a gyroscope here. Everything is still and only the middle part where moves. So now I'm going to have it moving really fast, rotating really fast. I hope it doesn't fall from my hand because it fell before and it was torn to pieces. I'm a bit clumsy. So yeah, if you have it like this, and you can hang it, no, like this, okay, let me do it again. It tends to stay perpendicular. Okay, let's do it one more. I'm really afraid it's going to fall from my hand. Okay, so so you have it like this, and it tends to return to its. Okay, it broke apart. I told you it was going to happen. Thank you. Okay, never mind. We're going to see this again in the end. Just pretend it never happened. But you understood the principle behind it. If it wasn't rotating, it would fall. But because it was rotating, it was kept like this. So the other sensor, which is less dangerous, is the light event. So what the light event is, it gives us information from the photosensors or similar detectors about ambient light. So it's these sensors here that are in the front of your phone. And they're used to calculate the brightness of your screen at night. And the luminance is measured in lux. So it is the perceived power of light per square meter. And again, this is the simple event listener. And again, they're using photodiodes. So if you see the third column here, I have a flashlight. So if you put a flashlight on, you see that it goes up to 4,000 or 5,000. But if you move it, it goes down. And if you cover it completely, it goes to 30. So these are using photodiodes, and a photodiode is a semiconductor device that converts light into electrical current. So our electronic device can read electrical current, obviously. And the last one is the proximity sensor, which detects the distance of a nearby object. So it uses min and max values, which are the the distance the sensor is able to report, and the value is the current proximity. So again, you have the device proximity event. And unfortunately, my phone does not support it, but I think in iPhone it is supported. We're going to test it later. It's the last column there. And it works basically, it emits an infrared light, and it looks for changes in the return signal. So yeah, some phones use this to detect when you have your phone in your ear, or some others, like mine, maybe use the light detector. So how we tie it all together? Sorry. First, let's see the connection flow. We have our phone. So the phone emits events. We have a node.js WebSocket server that's in the cloud. Or it could be a server we run from our computer, a node.js server, and it sends back events to our computer. Sorry. So within the mobile device, first, I don't know if you can see the letters. First, we open a connection to the server with the socket IO. So it's just simple as that. We connect the socket to mysocketserver.com, say. Then JavaScript is listening for device events. So we have the window added listener device motion. Then the device is moving. When the device is moving, the event is fired. And when the event is fired, a message is emitted to the server. The server event flow is the server starts listening to a desired port. So we open the server receives a message, and the moment it receives the message, it bounces it back to wherever, which is wherever is our laptop, say. So the message goes and comes back. But we need this bouncer to use it, obviously. So in the desktop, the event flow is like this. Again, we open a connection to our WebSocket server. Then the client receives a message. And on the reception of the message, message is received and passed in our component. Some RxJS magic is happening here. And RxJS, the subject subscribes to these messages. And then in each new message, the motion type is checked. If it's orientation, if it's motion, if it's whatever. And the view is animated and updated. And then we can interact with it remotely. So the server code is just this bit of code, almost. So you open the server and everything, and when you receive it on message reception, you emit the message back. So the full code is this. Let me just make it bigger if you want to see it. So yeah, it's just simple as that. You import Express, you import Socket.io, and you just choose a port, and you open your server here. You are just listening to a specific port, and then you connect it. And then you have your message received and then message emitted. It's very, very simple. And I didn't write this. I mean, I wrote part of this code, but it was just a basic example of Socket.io. I just added the bouncing thing from the message reception and bouncing off. So it's very simple. You can use it like this. So as you're going to see, you have a lot of issues with calibration. And the reason for that, let me open my browser to show you. The reason for that is because not all devices have all sensors. Also, not all devices have the same frequency in obtaining data. Not all device sensors have the same sensitivity. I mean, my phone can be very sensible, whereas an older phone or a different phone can not have so much sensitivity. Not all browsers use the same coordinate system. Browsers do not handle the coordinates the same way. And even if a device has a sensor, the browser might not support reading it. Like, for example, given the light sensor, I think can only be read from Firefox. This is because it's still in experimental state, so if you go to Mozilla Docs, you're going to see a big red thing saying that it's still experimental technology, but still we're using it today. So what can you do with the measurements? In terms of visualization, orientation is easier to visualize since it's just numbers within a range, it's from 0 to 360, say. And acceleration and motion numbers are more arbitrary and sometimes less accurate because motion detection can be different according to the sensitivity. So, no, don't go there first. First, let me show you. So, say we have my phone here, and we have this kitty that moves. So as I'm rotating my phone, the kitty is moving. Maybe somebody else is logged in, I don't know. But yes, according to my phone, the kitty is going to be moving back and forth. Or if you see the scenery here, if it's really bright, there are no clouds. If it's starting to get darker, clouds are coming, clouds are going. Yes. So yeah, these are all SVG animations. And you have this cube. Let me refresh. So you have this cube here. So if I have my phone facing up, the cube is coming towards me. If I have my cube facing down, the cube is going up far from me. And I rotate my phone, the cube is rotating. So we can now, I think, all play. If you can go to your mobile device on this address. If you have Firefox, use Firefox because you will be able to use the light sensor. If you don't, just use Chrome or whichever browser you want. Let's experiment. Mind you, I haven't run this test with so many different users. The maximum users I've had was 4. So we're going to see some things that I haven't seen before, but it's okay. There is always room for getting better. So when everyone is ready, everyone is ready? Okay, if somebody is not ready, just shout out and I'm going to go back again. So if we start with the cube, it's not responding at all. Okay, this is a disaster, isn't it? No, it's not receiving anything. Yes, it's not receiving anything at all. Maybe it cannot handle so many users. I've just deployed it to Heroku. I don't know how many users Heroku can handle. Yeah, so if some people log off to see. Okay, this is a crash test, obviously. Okay. Okay, some people log off. Okay, let's see what's going on here. Service unavailable. Okay, obviously there is no access control. Yeah, no, this didn't happen before, so obviously there's another problem. Maybe it's overloaded. I don't know. I know I should have tried it with 1,000 users, but I didn't have 1,000 users. Okay, some numbers are there, actually. So yeah, if we go to the kitty, we're going to see it moving, maybe. So if you just, the kitty moves according to the device motion. So if you move your device a bit up and down, maybe we're going to see it move. Or not. Let's see this. Okay, it's doing something. Okay, I'm really sorry about that. The clock is not moving. Well, never mind. Maybe I'll deploy it elsewhere another time. Okay, let me try one more thing. Okay. Let's try one more thing. If I switch, okay, first, so what, okay, let's try to find a workaround in 2 minutes, because I have 4 minutes left. If we don't find a workaround in 2 minutes, let's leave it. Okay, so what I'm going now is I'm going to see my local IP address, so it's this one. And I'm going to run the server locally because maybe Heroku cannot handle all this. Node. Okay, so now we're running the server locally. And if we go to our Angular code and we change the port we're listening, the address we're listening to. This is the mobile application. Okay, this is my application. So if we change this to HTTP, our code, and port 5000, then possibly we're going to see something happening or not. Yeah, but we have to change the... Never mind, because then you will have to log on to my phone as well, so... Well, never mind, we're not going to see it working perfectly. But you saw it working with one phone. I promise you it works with up to 4 phones. Thank you. So, okay. So beyond this, what are our future aspirations? Well, first of all, make it work for as many users as I can, as we saw now. Better calibration, because you need to calibrate your readings better. Better support for device sensors. This relies mostly to other parties. More uses, like use this to control a website, the UI of a website, like move your phone and open a menu, or click a button, or choose a button. So maybe I'll do this in another presentation in the future. This is not very secure at the moment, as you might have noticed, because the server is just 2 lines of code, and it doesn't take care of security. And also, it's maybe a bit inefficient, since it's a 2-way route, whereas in reality, my phone is only sending, and the laptop is only receiving. So I'm not using yet the 2-way communication exactly, both on my phone and my laptop. Only the server takes care of that. And also, different users are not treated differently, so they could be distinguished in different demos, or I could make a cap for maximum users, obviously. And that's all. So yeah, this is a photo of my vacations. I always like to show something of Greece. You can follow me on Twitter, please do. You can find the code from today in my GitHub, and my slides are there. I'm going to tweet them too, so you don't have to rush and copy if you want to, the address now. And the last slide is my sources, so you can see them in the slide afterwards. I'm just leaving this here if you want to. So that's it, basically.